Now we are getting ready to look at frequency distributions of continuous data, and there are two different ways of handling upper class limits with continuous data. One is called cut point grouping and the other is called limit grouping. And the only difference between these two is how the upper class limits are handled. So let's take a look at them individually. First, we have cut point grouping. Our textbook does not use this method, so we won't have any examples or homework problems that use it, but it is very common, and you're going to be seeing it in the real world, so I wanted you to at least be familiar with it. This kind of grouping is most helpful with continuous data that has several decimal places or a varying number of decimal places. So look closely at it. You can look at the lower class limits and see that the class width is 4, but notice the upper class limits. It says 10 to under 14 and 14 to under 18. So if you just casually glanced at it, you might think that 18 could go in either the second class or the third class, or you might not realize that the word under is there and you might not think it's very important. But the word under is very important here, because if we didn't have the word under on each of these upper class limits, then it would be possible for a 14 to fit in either the first or second class, for an 18 to fit in either the second or the third class. So the word under is what keeps the classes from overlapping. But because we do have the word under, that allows us to handle any number of decimal places. A 13 or a 13.99 or a 13.999 would all fit in the first class, and we don't have to know in advance how many decimal places our data will have. Now let's look at limit grouping, and this is what our textbook uses. So I want you to notice that the upper class limits here are not under anything, but it's definitely going to include this 13.9, and it stops there. So there's a little gap between the classes, but it's not a gap that's going to matter to our data, because the data in this frequency distribution would only have one decimal place. So everything will fall in one class or another. This is the same type of thing we were doing with our discrete data. So I think that's one reason that our book likes the limit grouping method, is that it's not a change from what we were doing before. Now, in this case, like I said, the upper class limits are obviously different, and we don't have the word under. And a data value with more decimal places than the class limits have would need to be rounded off to determine what class it should go in. So, for example, if you had a data value of 21.91, that would need to be rounded to 21.9, and that would fit in this third class. But if you had a data value of 21.97, that would need to be rounded to 22.0, and that would need to go in this fourth class. Pull together. Now let's do an example together. Suppose you're considering investing in a Roth IRA. You collect the following data, which represents the 5-year rate of return in percent adjusted for sales charges for a simple random sample of 40 large blended mutual funds. Construct a frequency and a relative frequency distribution of the data. Use a class width of 1. So let's scan the data here and find our smallest value, because we need to make sure that the first lower class limit is small enough to accommodate our smallest data value. So here I'm seeing 8.28. Okay, I don't see anything smaller than 8.28. Okay, so since we have to have a class width of 1, I'm thinking 8.00 will be a convenient first lower class limit. And then class width of 1 means I'll just add 1 to get the lower class limit of the next class, and so on. And I need to have enough classes to accommodate my largest data value, which is 19.43. Okay, now for the upper class limits. Because all of our data values have 2 decimal places, we will need for the upper class limits to have 2 decimal places. So if the second class starts at 9.00 and we don't want to leave a gap, the upper class limit of the first class needs to be 8.99. And then we'll just fill in all the way down. The next one would be 9.99 and so on. And now you can see that our largest class will hold our largest data value. Okay, let's go ahead now and sort these into their classes. We'll start with 10.94 and we'll go down. 10.94 would go in the third class, 10.53 as well, 14.12 in that class, 12.26 and 12.17 both in this class. And that's the first column. Then you can do the second column, 14.6, 13.98, 14.88, 14.2, and 10.26. You can see those there. And now I'm going to let you just fill in the rest of the columns. And there are our tally marks. Now I didn't really leave room here for a column for the frequency itself, so I'm just going to kind of wall that off and total up my frequencies. So the first class has a frequency of 2, then 4, and so on, and I'll let you total the rest of those up. Okay, now we can do our relative frequencies. Remember that the problem said we have 40 data values here, so to find the relative frequency, we'll divide each of these by 40. So 2 divided by 40 will be 0.05, and second class the same, and 4 divided by 40 will be 0.10, and then I'll let you fill in the rest of those. And so these two classes here actually should have relative frequencies of 0. We never want to leave them blank. Now if you really think about this frequency distribution, I mean it's okay, but look at all these teeny little classes that we have, and even 2 of them are empty. And so this frequency table may have too many classes. It may not be doing as good of a job summarizing the data as it could. So on the next slide, we're going to take the same data and sort it into a frequency distribution using a class width of 2. So that's what we have here. Now we already know that our smallest data value is 8.28, so it seems wise to stick with a lower class limit for the first class of 8. And if we use a class width of 2, then 8 plus 2 will be 10, and then 12, 14, 16, 18. And we still have 2 decimal places here. So since the second class starts with 10, we now need the first class to end with 9.99. And the third class starts with 12, so this will need to be 11.99. You can just take each upper class limit and add 2 to each one to get the next one. And now if we sort the data, we'll see something a little different. We'll start with 10.94 again, and that will go in the second class. 10.53, 14.12 now goes in the fourth class, 12.26, and then 12.17. And I'll go ahead and do the second column with you, and then I'll let you do the rest of the columns on your own. Okay, here are all of our columns, and again I didn't really have room for another column of just frequencies, so I'll make my little dividing line there, and we'll total these up. The first class should have 4, the second class should have 5, then 19, 10, 1, and 1. And we still have 40 numbers in our table, so let's divide each one of these by 40. And you can see that now we don't have any empty classes, and so probably the histogram that goes with this frequency table will look a little nicer. Now we are ready to construct a frequency histogram for each of the last 2 frequency distributions that we made. And we'll start with the one that has a class width of 1. And I've copied it here for us so we can see it while we make our histogram. And the first thing we need to do is label our axes. And I noticed that the tallest bar on our histogram is going to be 13 units tall. Remember, we're doing a frequency histogram, not a relative frequency, so you can disregard this column of purple numbers. We'll be using the red. And our tallest bar needs to be 13 units tall. So I'm going to label our vertical axis counting by 2s all the way up to 14, and that will make our tallest bar come about here, which is pretty close to the top, so I think that's pretty good. And now we need to label the horizontal axis. Notice that the first class that we used starts at 8, so technically I should start here at 0 and count out to 8, but that would be a lot of blank space before we get to our first bar. So what I'm going to do is put that little break symbol to indicate that we have taken a shortcut, and our first tick mark will be at 8. And so now I'll put a tick mark for each of our lower class limits, including the 20, which will be the lower class limit of the next class after our table. Let's go ahead and label those. And I think at this point it might be very tempting for you to want to center the bars over these numbers because all the numbers are here. It's not obvious at this point, if you're just looking at the coordinate system, that our data has been sorted into classes. So you have to look back at the frequency distribution and remember that these two values that fell into this class were not both exactly 8, and these two values were not both exactly 9. Instead, this frequency represents two numbers that were between 8.0 and 8.99. So we would definitely need the bars to be between the lower class limits instead of centered over the tick marks like we would have with single value grouping. So my first bar is going to be between the 8 and the 9, and it's going to be 2 units tall. I'll put that here. And the second bar is also 2 units tall. And the third bar is 4 units tall. And then the next one is 1 unit tall, then 6, then 13, 7, 3, 1. Leave these next two blank. And this last bar will be between the 19 and the 20, and it is 1 unit tall. And so there is our first histogram representing the frequency distribution that had a class width of 1. Now let's construct a frequency histogram for our frequency distribution that had a class width of 2. And I've copied that one for us here. And just like before, the first thing we need to do is label our axes. I'll start with the vertical axis, and I see that the vertical axis needs to go up to at least 19. I think for convenience I'll count by 2s and let it go up to 20. And now let's go ahead and label our horizontal axis. And again, we don't have our first bar until we get to 8, but I don't want to count out to 8 here, so I'm going to put that break symbol again, and then I'm going to label each lower class limit, including the 20, which would be the lower class limit of the next class. And let's go ahead and draw our bars. So between the 8 and the 10, we'll have a bar with a height of 4. Between the 10 and the 12, we'll have a bar with a height of 5, then 19, then 10, then 1, and 1. And now before we go on and look at how to construct histograms on the calculator, I really want to make sure you understand that we don't have a right histogram and a wrong histogram here. We have two different histograms. You might prefer one over the other based on what you intend to do with the data. Let's just look back at the first one. There's the histogram with a class width of 1, and there's the histogram with a class width of 2. This one certainly sacrifices a little detail, but that also might make it easier for somebody to read and comprehend, and it very well might be faster to construct the frequency distribution that leads to the histogram with a smaller number of classes. But again, either histogram could be the right histogram depending on what you need to do with the data. Now it's going to happen from time to time that you're going to have a large data set like this that you want to see the histogram for, but you don't want to take the time to draw the histogram yourself. You just need a quick glance at it. So I'm going to show you how to get the calculator to generate a histogram for you. And I'm going to assume while I go through this that you have already learned how to enter numbers into a list in the calculator. And if you haven't, then you want to go back to Canvas and watch the video on the introduction to the calculator. But if you have, then I'm going to show you here that I have entered all 40 of these numbers in our list. So you'll just want to press Stat, Edit, and you can see here that I have these 40 numbers entered, and you can enter these 40 numbers now if you want to pause the video and just get those entered. It doesn't take but a minute. And the order that you enter them in doesn't matter, so you could go down the columns like I did, or if it's easier for you, you could go across, but that seems a a little more tedious to me. So pause the video and then start it back up when you've got these 40 numbers entered. Okay, now let me show you how to access the statistical plots in the calculator. If you'll look at the label right above the Y equals button, you'll see that it's labeled Stat Plot, and that's where we want to go. So you're going to press second Y equals. Second Y equals, and you can follow the key presses over here if you want to. Now this is the screen that controls the stat plots. The calculator will allow us to use 3 separate plots, but I never need more than one at a time. So I keep the second 2 off, and I just use the first one. So what we're going to want to do is, with the first one selected, press enter down here. And now notice that this stat plot is off, but I need it to be on. So we're going to press enter again, and now see that the on is highlighted, and now we're going to change the type of graph. The first type is a scatter diagram, which we'll talk about in chapter 4, but what we want is a histogram. So arrow down, and now right arrow twice so that the histogram is highlighted and blinking, and now you'll need to press enter to have the histogram activated. Okay, now X list should be list 1 or wherever you have your data stored. When I have just a list of numbers like this, I always put it in list 1 because that's the default setting of the calculator, and frequency should be set to 1. Now with all of that set, let's go ahead and press graph right here. Okay, now this is the standard graph. If you've not used your calculator before and you've not zoomed in on anything before, this is probably what you're seeing. Although if you're seeing something else, it's no problem. I'm going to show you how to set it the way you want it set. So this is the default setting. Let's have the calculator zoom in on the histogram. So I want to show you, if you press the zoom button, if you scroll down to option number 9, or if you just press 9 right here, it will zoom in on whatever statistical plot you have activated. And so this is the default histogram that we're seeing, but the drawback of this histogram is that we've allowed the calculator to choose a class width for us. And what if we would like to choose our own class width? Like, remember, we had a class width of 2 the second time we did this graph. So let's set the calculator to show us this histogram with a class width of 2. So what you're going to want to do is press the window button, and let me explain this screen to you. The X min and X max are the furthest left and furthest right value that the calculator is going to show. The X scale is how much each tick mark is worth. The Y min and Y max are the lowest and highest points that the graph will show, and the Y scale is how much each vertical tick mark is worth. And then X res you don't need to worry about at all, that's just 1. Okay, now here's what we need to do. We need to set X min to be the lower class limit of our first class, which, if you remember, was 8.00. So go 8 and then enter, and it's 8.00 by default. And X max, let's see, our largest value in our table was 19.43, so I think an X max of 20 will be large enough, so let's just enter 20 right there. And then X scale, put in whatever you want the class width to be. X scale is whatever you want the class width to be. So our class width, the first time we did it was 1, and the second time we did it was 2. So let's go ahead and try it with 2. All right, now Y min, you don't need to see anything below the x-axis. You don't need to see any negative Y values, so Y min can be 0. And then Y max is as tall as your tallest bar. I don't remember what the frequency distribution said, but just as a guess, I'm going to say 15. We'll see how that does. And then I always leave Y scale 1. And now let's graph. Okay, so here you see that my tallest bar is going right off the screen. So what I'm going to do is go back to Window and change Y max to 20. And now I'm going to graph again, hit graph. Okay, now I can see my tallest bar. This pretty much looks like the graph that we generated when we drew it by hand for the class width of 2. Now if you'd like to see a class width of 1, all you need to do is go back to Window, change the X scale to 1. So I'm going to down arrow, change X scale to 1, and then graph again. And if you remember, that's pretty much what our histogram looked like when we had the class width of 1. Now, I would also like to show you one more thing. If you can't count these tick marks, well, you're not alone. I can't either. So I would like the calculator to tell me how tall each bar is. So if you'll press trace, the calculator is telling me here that this first bar goes from a minimum of 8 to just under 9. See, that's that cut point grouping that we were talking about at first. And it's telling me that in that bar there are 2 data values. Now you can right arrow and the calculator will just go 1 bar at a time. And for each one it will tell you the lower class limit and the upper class limit and the number of values in that class. So let's right arrow a few more times. So I think now I'm on the 4th or 5th class, and it's telling me that this bar is for the class that goes from 12 to just under 13, and there are 6 data values in that class. So you just keep hitting the right arrow until you get to the class that you want. So I think that's just a great feature, and I want you to practice with it a little bit while you're doing your homework, and just make sure that you're comfortable with it, because on a test you might want to draw a histogram. It's very likely that you'll have a problem that asks you to choose the correct histogram, and you'll want to be able to get the calculator to show you which one is the right one. Now I do want to do one example with you where we choose our own first lower class limit and our own class width. So let's look at this example together. The volume of a stock is the number of shares traded on a given day. The following data in millions, so that 6.42 represents 6,420,000 shares traded, represents the volume of Altria Group stock traded for a random sample of 35 trading days in 2014. If 6 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. Okay, so let's find the lower class limit for the first class first. And what we need to do is look through our data table and find the smallest value. And the smallest value I see is this 6.42. So remember that we want our first lower class limit to be a little smaller than our actual smallest value. And we want it to be a nice convenient number. So probably 6 is a good choice, because that's the first whole number that's less than our smallest value. So I think 6 is fine. And now let's go ahead and find the class width. Remember, we find class width by subtracting the largest value minus the smallest value. I believe the largest value you're going to find here is this 23.59. So let's do largest minus smallest. And then we divide that by the number of classes we hope for. And remember, they asked us to use 6 classes. So I'm doing largest value minus smallest value, and I'm dividing by 6. And that gives me about 2.86. Now, I'm not going to use 2.86 because that would be so inconvenient. And a frequency distribution is all about helping us understand the data, not making it harder to understand the data. So I want to round this number to a convenient number, and I need to always round up. Even if this number were less than 2.5, I would still round up to something convenient. So I'm going to go ahead and round up to a class width of 3. And now let's make our frequency distribution and our relative frequency distribution. So if we start with a first lower class limit of 6 and we want a class width of 3, then 6 plus 3 is 9, and then plus 3 is 12, and keep going until we can see that the next lower class limit would be bigger than our biggest data value. So the next lower class limit would be 24, but I don't have any data to go in that class. And now let's go ahead and get the upper class limits. So all of this data has 2 decimal places, and if I want 2 decimal places, then this upper class limit will need to be 8.99, and this one will need to be less than 12, so 11.99, and just keep going until we're all finished. And now I'm going to have a place for my tally marks. If you want to pause the video and sort this data on your own, you're certainly welcome to. I'm not going to drag you through it again because I figure by now we probably all know how to make tally marks, but I'll just go ahead and get them all down there. And now let's sum up our frequencies. The first class has 15, the second class has 9, and 4, 4, 2, 1. And our relative frequencies are easily found if we just divide each number by 35. So there's our frequency distribution. So now we are going to have the calculator draw this histogram for us, and I'm assuming you've already entered your 35 numbers into your list 1, and if you haven't, now would be a good time to do that. But if you have, let's go ahead and have the calculator graph this histogram for us. So let's press graph, and if you have your zoom set at standard, this is what you see. If you have it zoomed in some other way, you may not see anything at all, and that's fine because remember, we're going to control the window ourselves. So if you press window here, you can set, remember, the left and right and the low and high yourself. The X-min needs to be the lower class limit of the first class, which we had as 6. So we'll press 6 here, and then arrow down. And the X-max needs to be the upper class limit of the last class, or what I'll usually do, instead of using the upper class limit, just to keep it a whole number, I use the lower class limit of the first empty class. So I'm going to say 24 here. You know what I mean? Because the upper class limit of the last class is 23.99. 24 is a better choice because it's whole. Okay, now X scale, remember, was our class width, so we had 3 as the class width, and Y min doesn't need to be anything less than 0, that's fine. And for Y max, if you can see your frequency table, go ahead and set it just maybe whatever our tallest bar is plus 1. If I remember right, it was 15 or somewhere in there. I'm going to go ahead and set this for 15. And then I'm going to graph. Let's see what we get when we graph. Oh, and then that's a little close to the top. It's kind of hard to see. So let me go back to my window and change Y max to something a little larger, maybe 18. And we'll graph. Now that looks more like it. That pretty well matches what I believe our frequency table said. So if you press trace, remember, it will tell you what's going on with this histogram. So in the first class, the numbers go from 6 to less than 9, and there are 15 data values in that first bar. Then right arrow, the second class goes from 9 to less than 12, and there are 9 items in that class. And then we have 4 in the next 2 classes, and then 2, and then 1. And so that mirrors our frequency table exactly.